All right. Well, thank you, gentlemen, for being here. As you've been listening to the program this morning, we've all seen a lot and heard a lot about sustainability. It's come up in many different contexts and even the specifics of sustainable aviation fuel. So great that we're going to be able to dig into this a little bit more. And what I wanted to do is to kind of start with the fact that the industry's has a goal of net zero by 2050, which in some ways isn't that far away. So I wanted to get a sense as we dig into the questions here on your thoughts on how that goal plays into the operations of your companies, and do you think that not just the industry and your companies themselves, but all the different stakeholders that are involved and necessary to help you get to those goals, are they on track? Are we doing what's necessary? So to jump right into this, Chris, I want to start with you and with Boeing, looking at the longer term, how you view the future of sustainable aviation fuel, kind of the viability of that fuel, but also the other potential fuels like electricity and hydrogen as well.
Sure. Well, I'll start with the first part of that question. And, I think first I'd just like to thank the Chamber. I was thinking this morning on the way in, it was 107 years ago, I think President Wilson established the National Advisory Committee on Aeronautics because this industry is so important to the country. And I think the societal benefits of this industry we can't take for granted. And I think sometimes when we're outside of our aerospace audiences, we have to remind the world of that now, because from a sustainability point of view, we are visible. And as Dave said this morning, we're 2 to 3% of the world's carbon emissions. So I think the pressure and the expectations on us are going to continue. And that's really why we set up sustainability as an organization. I'm an example, I think, of how we're folding it into our operations. I have a full-time job now as the first Boeing Chief Sustainability Officer. We modified our board committees. We've modified our strategy to be explicit on this topic. We've modified our values. I've got a full-time organization. We've also got a full-time global organization headquartered in Amsterdam. We've got a full-time chief engineer who's focused on future mobility. So it's just, it's inside and deeply embedded in our operation. And then on our own emissions, for Scope 1 and Scope 2, for those of you that know that language, and our business travel, we did get to net zero in 2020, and we did that by buying some of the carbon offsets to do that. But so it's running deep through our organization, and I think sustainable aviation fuel has been talked about a lot, but we view that as a necessary component of getting to net zero by 2050. We don't view it as it's SAF or electric, or it's SAF or hydrogen. I think we believe sustainable aviation fuel is going to be required alongside the continued fleet renewal and operational efficiency improvements that our airlines deserve a ton of credit for doing, even during the pandemic. So that fleet renewal needs to continue, those operational efficiency improvements need to continue, and we have to focus on what we can do with electric and hydrogen. But our view is that no matter what we can do with it, we're going to need a lot of sustainable aviation fuel in the industry.
Great, thanks, Chris. Martyn, of course, Embraer, of course, has been working in collaboration with companies like Pratt & Whitney, to expand the use of sustainable aviation fuel. So I wanted to ask you if you could talk about the importance of that type of collaboration within the industry to help us achieve the ambitious goals that we're all talking about.
Thanks, Marty, and thanks for having a chief commercial officer on the table as opposed to somebody who's a technically professional or coming from the chief sustainability option. I think now the challenge is across the board in our companies. It's a topic for most of my conversations when I talk to airline seniors is about sustainability. So it's relevant now for everybody in the organization, including myself as I look to position it. And when it comes to collaboration, collaboration has always been important in our industry, always been important. An aircraft needs an engine needs an aircraft, you need to get the fuel there. There's always a great deal of collaboration as we've worked together. But the challenges that we face before us now, whether it's with, as you point out, whether it's electric, hybrid, whether it's hydrogen fuel cell, hydrogen gas turbine, whether it's sustainable aviation fuels, these are massive challenges that need huge amounts of collaboration, be it between the engine OEMs and the aircraft OEMs, be it in the distribution, be it in the airports, government bodies, because ultimately, if you look at the challenges we see now, take battery technology. You can't get over the fact that batteries don't have the density that you get out of JA1. It's a fact. So you need to be creative, you need to adapt. We welcome all innovation in the industry. And me personally, I think you absolutely have to work across the board as in one entity, right? Whether it's Boeing, it's Airbus, it's Pratt & Whitney, GE, whether it's the SAF production. And we will get there if we do that. I mean, Embraer has been working, we've done an eco demonstrator in 2016 with Boeing. On our EVE, electrical vertical and takeoff and landing enterprise, we've got partners like BAE Systems or Thales, airlines, we announced with United as well recently, a whole ecosystem of people involved in that. We will do further collaborations. We've got Widerøe, a leading regional airline in Europe, and we've been working with them on joining our Energia program and looking at examining how all-electric aircraft can work in the regional space in Europe. Because it's more than just sitting in a room, as we discussed earlier, Marty, sitting in a room, coming up with an invention and then producing it to the world. It's a more interactive process now.
Excellent. I appreciate that. So Graham, bringing you this here, ask how you see, how is Pratt & Whitney approaching new engine capabilities to help achieve all these goals?
So at Pratt & Whitney, we support a broad range of markets within the industry that span from general aviation, helicopters, APUs, civil aviation, and military. And so that broad range of customers are all looking for one thing, and that is improved engine efficiency. That's something that we get from all of our airframers. And so it's been a focus of ours for a very, very long time, dating back to our foundation. 1925, Fred Rentschler opened the doors of Pratt & Whitney. We joined forces with Bill Boeing and Chance Vaught in 1929. Same year, Charles Lindbergh had the first commercial revenue service that was offered for passengers. Back in those days, commercial revenue service was all about airmail, but they started off with passengers flying an old Ford trimotor that was powered by a Wasp, and they shrank what took a trip from New York to LA from 4 days to 2 days by using that aviation. Now, you couldn't fly at night, you had to fly only during the day. Fast forward 30 years, 1959, again with our partners Boeing, who had the 707, 4 engines. We had that JT3C at the time, was able to execute that same transcontinental trip in 5 hours. So within a 30-year period, we shrank the time that was required for people to go intercontinental or transcontinental. And so that aircraft was very fuel inefficient and extremely loud. But now, 60 years after that time period, our GTF-powered A321neos will make that same transcontinental flight in 5 hours, but with an 80% reduction in fuel efficiency and an attendant reduction in carbon dioxide emissions, and as well with a 7 to 8 time reduction in the noise signature that was present in those older aircraft. So as an industry as a whole, we have demonstrated the ability to innovate. And so as we look forward into the future, we're going to continue to innovate with our propulsion systems. We introduced a geared turbofan engine that saved 16% efficiency over the baseline at the time, 20% for Martyn's styles of aircraft. And we're continuing to insert new technologies into those engines in the traditional sense, the engine efficiency improvements, be it improving the bypass ratio, enlarging it, making the cores hotter and higher pressure so that we get the fuel efficiency. But at the same time, we're also playing in different spaces. We're playing in the electrification space with hybrid electric technologies. We've got a demonstrator running in Canada in partnership with de Havilland and Collins Aerospace, where we're pairing up a thermal engine with an electric drivetrain and delivering 30% efficiency from that combination, which has an attendant improvement in fuel efficiency.
Right.
Hydrogen is something else we're looking at in a longer range. But when we look at all of those improvements, we're still seeing that we need more than what we can deliver ourselves. We've been innovators for all of our history. We'll continue to innovate, but we need these alternative fuels to help us to get to the net zero target. And that's where the collective work that we're doing on sustainable aviation fuels is so important for us to enable to achieve that collective goal for the industry.
Graham, let me stick with you. I wanted to ask clearly this is about innovation. But as we talk not only just about the collaboration, but you and I were talking in the back room about how we talk about what the industry needs to do. And you made the important point that it's not just the aviation industry. There are a lot of different stakeholders involved in this. And maybe if you could take a minute to kind of describe.
Well, I mean, as I kind of ended on my last point, sustainable aviation fuels, as Chris indicated and Martyn as well, it's a key part of how we're going to achieve our overall objectives. But none of us make fuels, last I looked. And when you start backing up, you say, okay, well, how do you make these fuels, and how do you make sure that those fuels are actually better than kerosene, Jet A, that we're burning today? And so, you need to have clean hydrogen. That's a feedstock for making these fuels. Green hydrogen, or hydrogen that's generated without generating emissions. And then you also need to have a renewable source of electrical power. And so you look at these industries, you got the power industry, you got the fuel industry, they all need to come together to support our collective ambition to achieve net zero by 2050.
Excellent, great. Chris, when Mr. Calhoun was with us earlier today, I think he made some really important points. Obviously, commitment to the goals of reaching the net zero commitment, but that there also had to be some recognition that the pace is going to be important, and how policy is going to be important for how we don't take our eye off the many different balls that might get us to the, and those are my words, I'm saying those weren't quotes from him, so I don't want to put words in his mouth. But I wonder if you'd like to build on that or use that as how Boeing is focused now on really expanding the sustainable aviation fuel throughout your operations.
Yeah, I think for us, sustainable aviation fuel is really, I think of it kind of in three ways. One, we need to make sure that our products are capable of using it. The fuels that we have today are typically limited to 50-50 blends, and that would be a great next problem to have if every airplane was taking off with a 50-50 blend of sustainable aviation fuel. We don't have that much fuel yet. But I think first thing we have to do as manufacturers is to make sure we do understand what would have to change on our products, and that includes with Graham's help and GE's help and Rolls-Royce's help, including the engines. What may need to change if we were day in, day out operating these sustainable aviation fuels? Do we understand the implications to seals and fuel systems? Do we understand the implications to engine life, as Dave referred to this morning? So we have to do that work, and we shouldn't really wait to start that work until that fuel exists. And that's one thing. The second thing is we use fuel ourselves, not nearly what an airline would use, but we need to be a buyer, and we need to convert our own fuel use to sustainable aviation fuel. And in the course of lining up that access over time, it will require us to partner with people. And that sort of gets to the third thing. As a brand in the sector, alongside of our airline customers, we need to do what we can to advocate for the policies, to help the fuels get qualified as fast as possible, to make sure we're demonstrating those things. And I think about just the past year, the partnership with United to do a demonstration of 100% sustainable fuel, or Alaska Airlines was our most recent partner on the Eco Demonstrator, and we worked with NASA to measure the emissions and what kind of non-CO2 effects are we seeing in the emissions. And Sky Energy is a sustainable fuel partner of ours. Alder Fuels is a partner of ours. So we need to partner with people both for our own access, but also to make sure we're lending our voice or technical support to scaling it up. And if we think about the classic S-curve of a kind of an entrepreneurial startup, the challenge in our industry now is to bring that S-curve left for sustainable aviation fuel, while we continue to invest R&D in electric and hydrogen, and we can come back and talk about that some more if you want later, Marty.
Absolutely. No, I would like to do that. So, Martyn, with Embraer, we know you're developing a family of aircraft that would use a variety of, or a mix of different new fuel technologies. And so, building on your earlier comments and kind of where the conversation's going here, I mean, how do you view those emerging fuels over the long term?
To echo what's been said here, there's no silver bullet, right? Absolutely not. There's technologies that are available now, as Graham alluded to. There's technologies now that you can't afford to ignore that drive down emissions, like our next generation E2 aircraft, say 30% fuel burn improvement compared to previous generation aircraft. Don't ignore that. That has real and present, net present value of carbon savings right here, right now. We've got the MAX, we've got geared turbofan. These aircraft make a real difference right here, right now. And then you look at what? Like sustainable aviation fuels. We announced a partnership with Racing earlier in Brazil with the target of having all our fuels by 2030 having SAF blend. Okay, and we worked with Graham and his team at Pratt & Whitney on 100% SAF demonstration earlier this year for all the reasons that you've mentioned, Chris, as we pull together industry. And I think SAF has a huge role in that. And then on top of that, we need to look at the hydrogen and the electric and the hybrid. And as you alluded to, we announced earlier this year, or last year, sorry, the Energia program, which is 4 concept aircraft that we are working towards. The first one would be a hybrid aircraft, hybrid electric aircraft by 2030 that would have 9 seats and would do, say, 500 nautical miles, okay? And this is where you have to look at the challenges. We're not going to be putting a hybrid electric aircraft on a 200-seater aircraft and flying at that distance. You have to work and see how that goes. The next one would be, say, full electric 9-seater aircraft by 2035. And then you can even look at hydrogen fuel cells, 2035, on a 19-seater platform, again flying about 200 nautical miles. And then by 2040, maybe hydrogen into a gas turbine directly, up to about 50-seaters. And that's sort of the program as we see it. To the point, it's all of the above, right? All have their element to play. And you know, we have been the #1 regional player, you know, below 150 seats. We have a significant role to play, a significant responsibility to play in that, because that's where the technology is going to come to bear first, right? Due to the weight of batteries, due to the volume required of hydrogen, you know, due to the payload restrictions that are going to be there, it's going to be in the regional space that you're going to see a lot of these technologies come to bear first, and where we need to work on the commercialization of this technology, not just within the OEM space, but the whole ecosystem that both Chris and Graham have alluded to is going to be so important. So that's why we're working with many different organizations. I mentioned Racing there on the SAF production in Brazil, but many others.
Great. I want to turn in a moment to the importance of the kind of public-private partnership necessary and the role the government has to play in all this. But Chris, just to pick up on the, you know, I want to get both you and Graham, you know, digging a little more on hydrogen. So we've talked about it a lot. I think and again, my words that yes, but that's probably a proposition, you know, a little further down the road. But would invite
Sure.
first you, Chris, and then Graham.
Yeah, I think, you know, we kind of have this term we use inside of Boeing called SAF and. We think it's going to take SAF and whatever else we can do, not SAF or. And, you know, Dave mentioned the WISC joint venture that we have, the Cora airplane that you saw in the video. I think we're learning a lot about electric airplane design and certification with that. But I'd also fall back to the 787. It has about 1.5 megawatts of electric power on the airplane to provide some of the electric systems on the airplane. That was a step forward in electronic architecture for sure. And then we've got a partnership, sorry Graham, with General Electric and NASA on the Ph.D. program that's going to look at modifying a Saab airplane with megawatt class generators. So we're going to learn more about electric, I think. And then on hydrogen, I sort of like to say we should all want more green hydrogen in the world, because that would mean there's an abundance of renewable electricity in the world. And we're going to need a lot of renewable electricity to solve these problems, and that is what's required to make a lot of green hydrogen. And so we should want that in the world, and how it applies to aviation we have to learn about. We know how it applies to space, we use it in space, but we've started probably, I think it was in 2008, we flew our first hydrogen fuel cell electric airplane with a piloted airplane. It was a small one, a Damona, and we did that in Spain. And then as we went through the years, we've had 5 different flights of different types of airplanes on some form of hydrogen, liquid hydrogen, but mostly hydrogen fuel cells, including one last year with our subsidiary in situ with a small autonomous airplane where they 3D printed a hydrogen fuel tank and then used a hydrogen fuel cell to fly the airplane. And then most recently, with NASA support, there was a large composite cryogenic tank built and tested last year. Now, you know, it was tended towards space, but it was built with the 787 composite fiber material system, and it carried the equivalent amount of liquid volume that would equate to about the fuel on one of the regional jets that Martyn talked about. And so we learned a lot from that, including how you're going to control temperature and things like that at altitude. So we have to keep working on electric and hydrogen, and we will. But I think the other thing in our industry, for something to scale up in this industry and to take hold, the physics have to be possible, and that's why all this prototyping and innovation that's come into our industry is so amazingly good. And it's great from a talent point of view. But as soon as we think that the physics are possible, we have to think about how it can safely be certified, or it doesn't go any farther in the industry, and it's certainly not going to scale up, because that is the priority issue. And I think we see that, we're sort of in that space today on a number of the innovations that we've seen on eVTOLs and things like that. And then I think we get to the, is it viable from a infrastructure point of view or a use case point of view? And then is it achieving the climate impact that we wanted to achieve? And one thing we've learned, last point I think we've started to learn is, I think we in the industry have to consistently talk about the life cycle emissions of all the fuels. We've gotten used to talking about it when it comes to liquid fuels, or using a Department of Energy GREET model to assess the total life cycle emissions of our liquid fuels. But I think when we start to introduce the word electricity or hydrogen, maybe in our heads, we already assume those life cycle emissions are already green. And I think depending on where we're at in the world with grid renewal or how that hydrogen's made, it will have an effect on whether we're really achieving the carbon emission reduction we're after or not. And I think we have to be focused on that story no matter what type of renewable energy fuel we're applying to aviation in the future. And I think it's an exciting time, because we use this term, renewable energy is meeting aviation right now. And I think it's going to usher in the next era of sustainable aerospace.
Graham, get your thoughts.
Well, I mean, Chris, excellent job. You gave my speech on the need for all of these energy sources, renewable energy, green hydrogen. In our case, we're looking at, and we've worked with hydrogen. We powered aircraft, or developed an engine that could power an aircraft with hydrogen back in the 50s, working with Lockheed Martin. It was a project called Santan. So that's where we first really understood the challenges of, first of all, burning hydrogen within a gas turbine engine, and then as we looked at it, the implications of the volumetric energy density, which is 4 times that of fuel, which then really made the aircraft larger, draggier, heavier, and made it infeasible. And so based on that fundamental learning, if and when hydrogen does come to airports, our approach is going to be using the full benefits of cryogenic hydrogen to its maximum, not just burning it as we would jet fuel. And so we've come forward with a concept we call HySite, hydrogen steam injected intercooled turbine engine, which is effectively taking and burning cryogenic hydrogen. But what we're doing is we're using more of what that cryogenic capability provides, leveraging our experience from the space industry. We're going to condense water that comes out of the exhaust of that engine. There's 250% more water vapor present in hydrogen than there is Jet A. We're going to then take that and heat it in the exhaust stream, make steam out of it, use that to control the hydrogen combustion flame, which is very high speed and very hard to manage within an engine that cycles like a commercial engine will. And at the same time, we're going to use water that we will also extract, and we're going to use it to boost the efficiency of the engine by intercooling it, and then as well cooling the turbine. And so the overall approach that we're using is a unique propulsion system, different in its architecture than what we have today, but it's going to deliver up to 35% efficiency over what our current best-in-class geared turbofan engines can deliver in terms of energy efficiency. And at the same time, it's going to address NOx emissions, which when we look at burning hydrogen, it burns very, very hot, and there's a lot of nitrous oxide emissions, which is another form of pollution. So our approach is going to drop NOx emissions by 80%. The last thing we haven't discussed with respect to hydrogen is contrails, which is an emerging science. We're seeing a number of folks in the universities, MIT, the folks DLR, Cambridge, and they're highlighting that contrails, yet another form of emission that we generate, is something that has to be avoided, and it may be actually as deleterious, if not even more so than carbon dioxide itself. And so we got to keep an eye on those. There's testing that is going to be going on that will enable us to characterize what happens up at altitude in terms of contrail formation with hydrogen burning engines. And I think that's going to inform us in terms of the design trades that we need to make if we're going into this new field of hydrogen burning engines, which, as Chris has indicated, is probably long-term, maybe not this by 2050, but perhaps in the following decades to come in the century.
Fascinating. So we got 3 companies now that are clearly committed to pursuing the reduced emissions and better efficiency in the engine and fuel technology here. So I wanted to ask each of you, and I'll start with you, Martyn. What are the major investments that are going to be necessary in the infrastructure and operations, and the role that that the government is going to have to help play to facilitate the types of investments needed?
Well, the investments, absolutely phenomenal what's required, right? I think we were talking earlier, it's what, 5,000 to 7,000 refineries will be required to get SAF up to what, 45%, something like by 2050, something like that. It's a huge amount of, now, they're not necessarily huge refineries, they're going to be distributed effectively globally. That's going to take a huge amount of private and public sector collaboration, really, to that. Because you need an environment where you can drive that entrepreneurial spirit that you do have. You've seen it here in the United States, where if you can create that environment, you can let the free market go on that, you will see this stuff that come to bear. And that's just on SAF. And then we can see on, again, when we talk about the production of green hydrogen, how do you move that hydrogen from where it's produced onto the aircraft? You've got different ideas on how hydrogen could be used in aircraft, whether it's almost like the espresso capsule system to put the hydrogen on the aircraft or not. I see the challenges we talked about here, the technical challenges. I'm thinking about the commercial challenges as well, the price of SAF. Okay? If the price of SAF is 4 times the price of Jet A1, it's an obvious headwind that it's very hard to get past, right? You can start blending it in, but to make a material impact, so we need scale of production. We need governments to work with private sector to drive entrepreneurial investment, to foster that environment. I think we will get there, and that includes on top of that, because it's not all, it's all of the above. How do we therefore work with battery technology, hydrogen, fuel cells? Personally, it's one thing that I think it's very easy to say, oh, it's not just aviation, it's all the industries you alluded to with hydrogen production as well, okay, as we work together. So huge challenges. I discussed before that the challenges sometimes can seem almost too much, okay? Is it realistic for these targets by 2050 for net zero? And I think Chris started talking before, what this industry has achieved today should be recognized. Okay? It's phenomenal what this industry has achieved. And I can only say that I think actually we're heading to the next 20 years, as some of our young engineers come in and our young graduates come into the company. I say you're about to see almost the most exciting period of aviation. Really be excited, be motivated, because you're going to see real material change now, right? And I think that investment, addressing a challenge, is also be seen as an opportunity, an exciting time for our industry to be seized upon by both the private and for governments to foster this, okay? Not just talking about incentives, removing barriers, creating a level playing field. I think there's a lot that can be achieved. I think no one can take their eye off the ball. I do actually think we can achieve these goals, but only with constant attention, not dropping the collective ball, working together amongst competitors, working together in one direction.
Chris, of course, we just had recent legislation enacted here that gives a blender's credit to help with SAF, but within kind of in that context, and then also just getting to where you see public-private and the investments that we're going to need to achieve these goals.
Yeah, I mean, I think we have to do our part on the industrial side, and I think it feels like when we're in some audiences, the conversation is really more about the capital it's going to take to be invested in facilities to either get them converted to this or create a greenfield facility around this. And then when you're in other audiences, it's not the capital, it's really the de-risking of the demand. and that demand de-risking gets you to the price equation, and what are these fuels going to cost, and can we forecast that with enough certainty that somebody would be willing to enter into a longer term contract and de-risk the demand. And so that's why I think, you know, everybody, no matter where you sit in the value chain, everybody talks about a policy. And I think, you know, there already are different policies emerging around the world, whether they're mandates in some areas or incentives in others. And I think that does help de-risk the capital. I'm hopeful because I see the momentum at the front end of the supply chain. You know, I think if you just looked at the number of fuel companies, the number of startup companies, the big oil and gas company conversations and partnerships, you can kind of feel hopeful that there's a transition of sort occurring, even though you can't yet measure that in the gallons of output or the liters of output yet. But I am hopeful that between some of those policies emerging around the world, and the feedstocks will be different. The feedstocks will be very critical, I think, to this, and they will be different around the world in terms of what's available or acceptable in one location or another. But we're learning. I'd say we're learning as a company, being global and having people around the world. We're learning about what some of the policy expectations are. But I do think some of the elements that have been proven here in the United States in places like California around what these low carbon fuel standards can help do, or the incentives that we need to bridge buyer and producer expectation in the beginning, or especially the idea of book and claim. That as this industry scales up, we shouldn't penalize people who want to book it in one place where it's available and claim it somewhere else, so we're not road trucking or shipping this stuff somewhere just to be able to say we put it in our own fuel tank. I think as we scale up as an industry, that policy element is going to remain very important.
Thanks, Chris. So Graham, in the same context, that the U.S. Chamber would like to think about, you know, we encourage these ambitious goals, but let's recognize that in order to meet any of them, we're going to need technology, the policy, and the market signals for the private sector to actually make the bankable investments to achieve these goals. So, kind of building on what Martyn and Chris said, get your thoughts.
Well, I got to pivot a bit from the fuel side and go into the aerospace technology side. We're all coming off of the backs of the COVID crisis. We all suffered tremendously from a business perspective, and there's a lot of investment. We talked a lot about it. For me, engine efficiency, electrification, hydrogen. There's a wide gamut of technologies that we're all evaluating at this point in time. And when we look at it, we do have the opportunity to improve the overall signature of the industry by fleet renewal. You know, we have a relatively large and healthy backlog of geared turbofan engines that provide the ability to reduce fuel burn and carbon dioxide. But when we look forward into the future, we have to go fast, because in order to make a difference, we have to have the technologies mature and ready by 2027, literally, to hit a 2035 entry into service for the new technologies for single aisle and even wide body aircraft, maybe later, that are going to really dominate the scene, 40,000 plus aircraft for the next 40 plus years. And so we need that public-private partnership with us in the industry to help us to stimulate, especially those low technology readiness level technologies that we all need in order to bring this home. And I'd have to state that in the case of propulsion, that's, you know, what I know the best is that it's been a good bet. When we've partnered with the government, we partnered with the FAA, we partnered with NASA on the early technologies for the geared turbofan engine, and that enabled us to deliver that product, which has saved, at this point, almost 1 billion gallons of fuel and a commensurate, 100 megatons of CO2 since it was introduced in 2016. And so that continued partnership with those entities, including the Department of Energy that I am partnering with respect to our hydrogen engines, is going to be necessary, and we need to really accelerate that progress in this time frame that we have the next 5 years, because that sets what's going to happen for the next 40 years.
Excellent. Well, gentlemen, we're come to the end of our time here. I want to thank you personally, but I hope I invite the rest of the crowd to join me in thanking our speakers today. Look forward to seeing you soon, too.
Thank you.